Hi YouTube, my name is Tyler Coyle and we're going to do another episode of Level Up Python. Today we're going to talk about loops, so for loops, while loops, list comprehensions, generator expressions, stuff like that. And hopefully I will introduce you to some new things about loops that maybe you didn't know before, or at the very least you get a little refresher on how things work. If you're aware from my last video on print, I had a mattress behind me. But since then we've changed it and now I've got this much grungier mattress behind me. You may see a cat in this tutorial jump up there. So that's just going to be a treat for us all if that happens. Hopefully soon that grungy mattress will go away though. But without further ado, let's go ahead and hop right into my text editor. So much like with my print video, I have a series of files that I have here on the side pre-created that I'm going to use to illustrate my points as we go through the for loops. Well, each time I'll kind of level up as we go, and then I'll make larger jumps from one file to the next as we go. And I'll call them out, and much like in my print function, I'm intending to put chapters in as well. So let's get started with our basic loops. To begin with, I've got a variable named users, which defines a list, or you might refer to it as an array, of various people's names. So I've got Crazy Bean, Sylphid, Tyler, and Zeno Tassadro. Might not be saying that right. I'm sure he'll correct me if I'm saying it wrong. Every time I see it, I want to say Zeno Tassadar, because StarCraft, but I'm just going to call him Zeno from now on. So we've got this list, and I really just want to iterate through that list and print out each item in the list. So the first one I'm going to show you is going to be what's frequently called the C style for loop. And by C style, I mean that frequently in compiled languages like C, you'll see this logic take place through it. Now it might look a little bit different, but I'll explain what I mean. So I'll go ahead and run it and just show that this gives me exactly what I'm expecting. Crazy Bean, Sylphid, Tyler, and Zeno. So when I say a C style, what I mean is we're getting the length of the array, then we're going to iterate through the numbers that make up that length and call from the array the index that we're passing on. So each time we're iterating through this will generate a list 0 through 3, and we'll say users position 0, users position 1, position 2, position 3. So this is actually a slow operation in Python, and it's kind of hard to read. Python has a much easier way to perform this operation, and a lot of people will call it Pythonic. If you want to know more about Pythonic, feel free to comment below and I'll give you some information on that. But here, Python has a much nicer scheme that you can use. You can just simply assign a variable for each item in the list. You don't need to run length on it. You don't need to create a range based on it. Just for name in users, print that name. I've seen in another video that Python for is compared to other languages for each. And if that's something you're familiar with, then that makes sense. You'll probably frequently hear me say for each throughout this video, but it's just another way to remember that for yourself. So let's level up a little bit. We know about the C style for loops, and we know about the basic Pythonic for loop, but what about a while loop? So a while loop we're going to start with is just a basic condition that says, hey, while this condition applies truthfully, go ahead and run this code for as long as possible. So in this example, we're going to say while true, which true is always going to be just true, we're going to print the phrase forever loop. Go ahead and run that. Now you may be noticing in my video that my webcam is starting to stutter. Because I'm recording from this computer with OBS, and I'm using a webcam that's connected via USB to my computer, and then running a Python script, I'm getting a lot of CPU time being taken up. So it's generally a good idea to include some kind of sleep within your operations, because you might be consuming more CPU time than you really consider. And this is just a print. I'm gonna go ahead and kill this. And sometimes it's hard to kill it because there's no wait in between the loop for it to wait for your keyboard interrupt. So I'm gonna give this a second. There we go. We killed it. So a good habit is to go ahead and put a sleep operation in between each loop or each iteration. So in this case, we're going to say sleep float of 0.1 after each print. And we'll see that it prints a little bit slower, but it's much easier for me to interrupt, and you likely didn't see my webcam even stutter. Let's go ahead and just run it again. Am I stuttering? Am I? All right, let's go ahead and level up a little bit further. We'll go to my second file, and here I'm going to have another variable of users, and I'm going to show you the pass keyword for the for loop. So I'll go ahead and uncomment this, and I'll explain what it's intended to do. So for user in users, so assign this variable for each iteration of test, banana, potatoes, Tyler. If the user does not equal banana, then pass. Else, we're going to say for throwaway variable in range 5, print peel the banana. So let's see that in action. Here we can see that we never see anything but peel the banana. And that's because, well, we're not printing anything but. So let me go ahead and put a print user in this first if not. So we should see the user regardless of if it's, let me rephrase that. Let me also not do updates. We should see every username except banana be posted. So we'll see first test, then the next phrase is banana. So we'll print peel the banana 5 times. Then we'll see potatoes. Then we'll see Tyler. Now, pass is essentially a no operation. That means, hey, Python, when you get here, just don't really do anything and just continue. Now, I said the word continue, so be careful with your terminology here because pass and continue are not the same thing. As you can see, pass I have here before print. We'll go ahead and run it. We still see test, peel banana, potatoes, and Tyler. Continue is a much different thing. I'll explain that in a second, but first I'll say pass is really just kind of a placeholder for saying, hey, my syntax and indentation here for the Python code is exactly what I want it to be, but I just don't want you to do any action yet. So for example, I use it frequently whenever I want to define a function, but I don't want it to do anything yet. We'll pretend that this is that scenario. If I just don't put anything indented behind this colon, let's go ahead and run this code and see what happens. We see that we get an indentation error because it expects there to be something executed here, but immediately we see else. So pass just makes that perfect placeholder to say, hey, I might be intending to do something here later, and this syntax is exactly how I intend it to be, but just don't do anything. So now let's get into the continue keyword, which, like I said, is different than pass. Your terminology does matter. So here I'm going to have the same list of users, test, banana, potatoes, Tyler. And I'm gonna uncomment this and I'm gonna explain what it does one step at a time. First, we're gonna say print listing all users. Then we're gonna iterate through each user and print out what that user is with a end and flush. And if you're interested in these keywords, I'll go ahead and leave a link to the print video somewhere on the video now that you can go ahead and go check out. Then we say if user is not banana, then we'll say that user is verified and we'll go ahead and use the continue keyword. If the user is not banana, which is implicit here, print, we're going to spam check that user. And then just to pretend that this is an intense operation, I'm going to use a throwaway variable and uncomment the sleep. I'm going to use a throwaway variable and print out checking 5 times with a 3-second sleep in between. And then lastly, we're going to say we're done checking. So let's see that in action. So we can say listing all users. test, the user was verified. Banana, we're going to spam check the user banana. We're checking, we're checking, we're checking, we're checking. It's going to take a little while. We'll see done checking, and then we see potatoes and Tyler, which users are all verified. So the continue keyword here basically says, once you see my continue keyword, continue on to the next iteration in the list. So where pass, if I had pass here, you can see when I run this, we'll do spam checking immediately on the test user. And then once this finishes, we'll also see it on the banana user. Then we'll see it on the potatoes user. Then we'll see it on Tyler, which isn't the intention that we want. We want it to say, okay, this user is specifically verified. You really don't need to do this complex logic anymore. So we'll go ahead and kill that, change this back to continue. So that's the continue keyword. Let's go ahead and level up a little bit more. I'll comment out this line, these lines. And let's look over the break keyword for the for loop. So here, same user or same user list as always, test, banana, potatoes, Tyler, slightly different order. And we're going to say for user in this list of users, we're going to first print out the user. And if the user is equal to banana, we're going to print, we found the banana, and break. So essentially, we're looking for the needle in the haystack. So we'll go ahead and run this and see what happens. We see test banana, then found the banana. Break is essentially saying, hey, for loop, I've completed whatever logic I want. Go ahead and break out of this for loop. I don't need you to keep working anymore. So if banana, for example, was at the end of this list, we would see it still iterate over each user. And even if banana was the last item, we're still going to follow that same logic. So let's take breakout for right now. And we're going to see the exact same output because it's the last item in the list. Now, the same thing would occur even if you didn't have banana in there. It still hits Tyler, potatoes, or test potatoes, Tyler, and follows the same logic, but the user banana never occurs. So break never gets hit. We just hit the end of the loop. But if we hit, or if we create banana, but spelled right, here at second place, we go back to our original state where we kill the loop as soon as the second user is found. We'll comment out this and we'll level up a little bit more. And let's talk about the else statement as it relates to for loops. So else is a little bit tricky. For me, it doesn't really make sense that the word is else, but there's really not a better word for it. Let me explain what I mean. So we have our list of users, and we're going to iterate through that list and define our user. We'll print out that user, and we'll say, if the user is equal to banana, we found the needle in the haystack, we're going to go ahead and break out. Else, print done searching for users. So let's go ahead and run it and see what happens. We can see we found the banana, and that's all that happens. The reason for that is because of this break statement. So let's go ahead and comment this out and see what happens in that case. We can see that test banana, found the banana, Tyler, potatoes, then we see done searching for users. I like to think of else as break or else. If you run across a break, then we completely bypass the else statement. Whereas even if this was an empty list, which is what I originally thought else was doing, meaning I had a lot of logic flaws in my code. I thought else was saying, hey, if the list is empty, let's just run else, which it does do that, but it also just doesn't as well. If it just finishes its for loop, it will still print out what's in else. So I originally liked to think of it as finally, but the fact that you can bypass your finally statement means that finally really doesn't apply either. So like I said, the easiest way for me to think about it is break or else. So that's a little bit of the break statement and else keywords. Let's go ahead and talk about the while loop and using else, and let's see how it functions. So I'm going to undo this test I recorded this video 2 other times prior and forgot to undo this. So we'll say test equals true, and while test is equivalent to true, we'll print test, else we'll print fail. So this would effectively be a forever loop. Let's run it and see what happens. We can see my webcam probably is shaky, but it is indeed a forever loop. Oh, I forgot to put a sleep in. Why did I do this? Okay, let's go ahead and uncomment this, and I'm gonna put a sleep in just so I don't do that again. Okay, so what happens if this test evaluates to false? So this equivalency test never returns a true response. This false does not equal true, meaning this should fail. Let's see what happens. And it does. In this case, else acts exactly like an if-else statement, where if this condition does not apply, let's run else. But since this was a forever loop, you're never going to see the else statement because, well, these conditions will always be true. And if you run break in here, well, let me just show you. I'll just call break. It'll do 1 iteration and then immediately break. Let's also set this to true. So we can see true, and then we hit break, and break bypasses else. We learned that before. So let's see what happens if we iterate out of a condition. So we'll say while test is less than or equal to 0, but only done right. Actually, we'll make it less than or equal to 10. We'll print test, and we will go ahead and increment test by 1. And this should effectively say that while test is less than 10, print out test and increment it by 1. So we should see it say 0, then 1, then 2, then 3, then 4, repeat till 10. And let's find out what this else statement does. So there we go. We see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we see fail. This represents exactly what we saw with the for loop. Else runs as soon as your loop is complete, but it can also act like a conditional false, assuming your for loop is not going to iterate out of itself. I would be careful with how you use this. I have seen some cases where they'll say let's say while server is not online, poll for it, and if it ever hits a state of failed, then they'll just hit fail. That logic can be sound, but if you have any kind of mistake, like say this one where I'm incrementing out of it, you might have this print fail, or maybe you raise an exception, and you could break your code because you didn't expect that this else would ever be hit because you're iterating out of something. I'm not saying it can't be done, just be careful. So let's level up a little bit more. We'll talk about a little bit more, another break example. So in this case, we're going to pull this down here because I don't know why it's up there. I have an import from random. I don't know why it went up there. My code or my text editor is trying to purposefully sort this and put my imports at the top of the file, which is good for me, but bad for this situation. So when I say this again, you're going to see this disappear. But we're importing from random the method random int, and we're going to go ahead and create a variable of roles equivalent to 0. And we're going to say while true, we're going to increment roles by 1, and then we'll roll a random int between 1 and 20. So effectively, we're doing a d20 dice. And we want to say if the random roll is equivalent to 20, print critical, then break, and then print it took this many rolls to crit. I'll save that. We saw the import go away. Let's go ahead and run this. And we can say, see, it took 13 rolls to crit. It took 7, took 22, took 6. So we can see in this specific case that as soon as we get this logic, we're going ahead and break out of our loop and just end it. That works just like how we saw in the for loop. It still worked the same as how we saw in the previous example, though in the previous example, I was going to illustrate else. Here, break works exactly in while loops like it does in for loops. I will say pass and continue work the exact same as how they do in for loops as well, but I'm not going to show you an example of that because I hope you just take my word for it. But that doesn't mean we can't level up. Let's start talking about list comprehensions and generator expressions. Here's where stuff gets real fun. So let's go back to our user list of real usernames. So we got Crazy Bean, Sylphid, Tyler, Zeno, Tassadar. And we'll go ahead and uncomment out this first line. It might look a little bit funny, but I have is greater than 5, and then name for name in users if len name is greater than 5, and I have that inside of brackets. Also, why is Slack blowing me up? So this variable, or this might look a little bit funny, but we have the variable is greater than 5 equal to brackets as to denote list. So you may think this code looks a little bit funny. I have a variable is greater than 5 equivalent to what looks like a list that says name for name in users if len name is greater than 5. You may notice that this looks pretty similar to a for loop. And that's because that's what it is. It's a for loop inside of a list. And we call that a list comprehension. So let's go ahead and see this in action. We'll call 3 and we see we get the output Crazy Bean, Sylphid, Zeno, Tassadar, Dassadro. And let's go over why that happens. So in a list comprehension, we're saying insert this item into the list for each name that we find in the users if the length of that user name is greater than 5. So we say this is whatever's in the leftmost is what we put into the list. Then we say what our iterable is, and then we can apply conditions. Now, this is a little bit simplified, but if we were to say that this was a number, you could even do actions here, like say name plus 5. So you can perform some logic here on what you insert into the list. But for our case, we'll just keep it simple. And we're saying any name that's longer than 5 characters, we'll insert into this list, and then we'll just print out the list. So Crazy Bean, Sylphid, and Zeno are all greater than 5 characters, whereas my name is exactly 5, so I'm excluded from this list. And that's the output that we get. Now, you might be thinking, okay, but why not just use a for loop? And let me show that example. We have gr_5 is equal to an empty list, and we say for name in users, if the length of the name is greater than 5, we'll go ahead and append that name into the list, and in the end, we'll just print that list. It just does the exact same thing. The difference is this is 2 lines, whereas this is what, 5. So you might be wondering, well, what's better? And to be honest, it really depends on your needs. There is situations where a list comprehension will be faster in code than a for loop like this. But speed isn't everything. You also have to consider how readable is your code. So to determine that, you need to understand who is the audience for your code. If you feel that your audience can easily interpret what a list comprehension looks like and how to debug it, then a list comprehension might be the best thing for you. But if you guys come from a different language or are completely new to programming and have never seen anything like a list comprehension, it might just make sense to stay with a standard for loop. Now, I'm not going to show the example, but I will say you can make nested for loops inside of a list comprehension. It's kind of a pain to do, it's kind of a pain to debug. Personally, I'm of the opinion that if you need to do nested for loops almost at all, your data structure might not be the most efficient. There might be better ways to do it, but there are legitimate cases to do it. But I'm not going to show it because I think I'll only confuse myself. So let's go ahead and move on. We'll comment this out. Well, you can go ahead and comment out our user section as well. And let's show you a dictionary comprehension. So just like normal, we have the same users, Crazy Bean, Sylphid, Tyler, Zeno. We're going to say the variable users and adders equals the key name, and the value is going to be length of name. So just like the list, insert this into your dictionary and then run your iterable. So for name in users, go ahead and insert into the dictionary their name and the length of their name. We'll print that and see what it looks like. So we can see we get a large dictionary of a key crazy bean with a value of 9, key sylphid with a value of 7, key Tyler 5, Zeno 11. Now this is great. I use dictionary comprehensions quite a bit, but I will note, just as a quick tidbit, this data structure is not most pleasant to work with, especially if you work with a language like Golang, where you kind of need your keys to be explicitly defined and not variant. If you were to export this to JSON, I'd probably be mad at you. Let's just be honest. So let's go ahead and talk about how we can make this data structure a little bit more formalized, a little bit more standardized, a little bit better, just better format. So we have our same user list. We're going to do the same thing. We want to provide the name and the length of the name, but what we are doing is a little bit different. We're going to create users and adders to equals a list comprehension of for name and users, but the item that we create in that list is actually going to be a dictionary. So for each username we find, we're going to create a dictionary with the key of the word name, whose value is the variable name, the word length as a key with the value of the actual length of the name. So let's print that and see what it looks like. So here you can see we get a list of dictionaries rather than just one large dictionary. This is great because there are some cases where, like I said, you need your keys to be explicitly defined. You don't want any variance. But what if two people were named Tyler? In this case, their length are both going to be 5, but let's say we had a different thing like eye color. My eye color is blue, but there might be another eye color or another Tyler out there with eye color of brown, and you may have just overwritten his eye color with mine. So it's always a good idea to consider what your data is going to do and how you're going to use it before you just jump into making something, because there's a good chance that you'll want to do something like this, where you say each specific user gets their own object rather than here's one object with all my users. So let's go ahead and comment this out and let's upgrade to a set comprehension generator. No, set expression. I don't know if it's a set comprehension or set expression. I am ill prepared. So we'll go ahead and save this, and we see we have users who commented in thread, and it's just a list of names. Got Tyler, Sylphid, Tyler, Crazy Bean, Sylphid, Zeno, Sylphid, Tyler, bot. And maybe it's like Tyler says hello, Sylphid said what's up, Tyler says nothing, Crazy Bean says nothing for me too, and he posted a tongue out emoji, and then Sylphid says you suck, and Zeno says no you, and Sylphid says butt futter, and Tyler says no you, and then the bot kicks somebody. I'm not saying that's what happened, I'm just saying that's what could happen. It's up to you to figure out if that's what's really happening. But what we want to do in this action is we want to get the unique names here. So for example, we see Crazy Bean in here twice, but maybe we want a list of usernames, but we don't want to see Crazy Bean in there twice. We can accomplish that with a set. So if we use unique users in thread, and much like how we did with a dictionary, we use curly braces, but don't apply the colon and then provide a value. This will treat it as a set in the Python interpreter. So we're saying just like a list, except with curly braces, user, insert user into the set for user in users who commented in thread, and then print it out. Actually, let's comment this out. And we'll see that we get Sylphid, bot, Crazy Bean, Tyler, Zeno. Now the order has its own characteristics, so if order matters to you, a set may not be the best thing for you. Sets actually use hash maps under the hood, so there is some logic behind it that explains how to predict this and if it is predictable. So that's just a little call out for you if you care about order. But for this case, we don't care about order. We now have a unique list of, well, I'm going to not say list, it's a set. We have a unique set of users who participated in this thread, meaning we only see each username once. And now a set can be used just like a list. We can iterate through it, and see Zeno, Crazy Bean, Tyler, Bot, Sylphid. Now, there are special characteristics to a set, and if you're interested in details about how a set works and what you can do, feel free to comment below. Maybe I'll make a video on that in the near future. But for this specific talk, just know that a set, it's pretty relatable to a list in this case. So let's go ahead and level up a little bit more. And let's talk about generator expressions. Generator expressions are tough. With the upgrade from Python 2 to Python 3, a lot of things changed from list creations to generators. And generators were just established to be a easy to use method of memory saving while still keeping track of iterable information. So let's say you had a list of 50 complex CPU-bound operations, let's say intense math. You could either do all 50 of those operations up front and wait 20 minutes for it to finish, or maybe you only care about one of those values once every hour. Would you rather spend those, I don't remember how long I said, would you rather spend 2 hours waiting for that entire operation to finish up front, or would you rather just take a few minutes when you actually need it? A generator can help you accomplish that. Or let's say you have a million item array that has a lot of memory space consumed in it. So let's say your array takes up 16 gigabytes of memory as a full defined array. A generator can help you make sure that you only need the parts in memory that you are going to use right here, right now. Now, there's a little bit more nuance to that, and I'm not going to get into it for right now, but just know generators are a lifesaver. If you were in Python 2 and you use range, you would probably know that a range creates a list. So let's say at range 10, it creates a list of 0 through 10, whereas xrange would create a generator. You'd use it mostly the same, but you probably saw xrange in Python 2 much more frequently. In Python 3, range is a generator, and they got rid of xrange, but that's my best example for showing you something relatable. So let's get into this. So let me show you a quick example of a generator expression. We'll go ahead and run this script. Whoa, Python 3 underscore, that's what we want. And we can see we get the output of 285. That's because, just like we do with most other comprehensions, we're saying perform this action for X in this range. So in this case, we're going to say X times X for X in range 10. So range 0, we get 0 times 0, we'll get 0. Once we get to 1, we'll say 1 times 1 equals 1, so on and so forth. But then we're summing it, and then we're just going to print out the sum. And 285 is what we get. Now, this might not be the best description or best way to show the generator expression, so let's just do a generator expression excluding sum and show you what output we get. Here, we're doing the exact same operation. We're just excluding the sum method, so we'll see the exact output. Go ahead and print it, and we get an object back. We don't see the actual contents of what I'm going to call this list. We just see the object that is a generator. And that's the big difference here. Everything else that we've done so far, list, dictionary, set, we can just print it out and we see exactly that. Now you might think that this should create a tuple. It doesn't. It creates a generator. And that generator has special methods to it that we'll go ahead and level up now and talk about. So first, I want to show you that the number of parentheses that you create doesn't impact what the results are. So if I go ahead and save it and run this, we can see we get 285, which is a sum, and these number of parentheses don't really matter. Frequently, you'll see just this simple 2 parentheses, which I'll go ahead and show you. And we'll uncomment out this print. Frequently, you'll see this simple 2 parenthesis annotation in a lot of people's code, My text editor will specifically get rid of it if I save this with formatting, but I have seen it where people do this to denote the fact that they are explicitly trying to do a generator expression. I'm making this call out because if you try to duplicate this in other scenarios, it might not do what you think. So we'll do Python 4, which is calling this s equals this generator expression, print out s, and we get a generator just like before. But let's try to do the same thing with a list comprehension and see what we get. We see that we get a list inside of a list. So you have to be very careful about how you do multiple annotations. So we'll comment out this and let's try it for a set and see what happens. Except I want to not do that. So go ahead and save this. And we see that unhashable type set. Like I said, sets use hash maps under the hood. So whenever it comes down to it, you can't actually put a set inside of a set. Otherwise, this would do the exact same thing as the nested list. So now let's show that example with a dictionary. We'll go ahead and uncomment out this. We'll comment out this one, and then comment this print. And let's just see what we get. Here, we get the same thing, unhashable type dictionary. But the reason for that is because we're trying to put a dictionary inside of a set. If you note that there's no colon here, that's what makes it a set. So if we put a colon, let's say 1 here, let's see what happens. Here, we get unhashable type dictionary again. That's because the keys in a dictionary are the hash map aspect of the dictionary, just like the sets are. If we were to change this to instead be 1: this dictionary generator, so that this is actually the value of the key 1, let's see what we get then. We actually get a dictionary with a singular key of 1 and a value of the entire dictionary expression that we created. So hopefully that taught you a little bit on how you can nest things inside of each other and see how they function. But the important thing is you have to be careful with this, whereas multiple parentheses around a generator expression really doesn't matter too much. Let me show you one more example of how you need to worry about your parentheses. Here, we're going to exclude them. You might think that this is going to be the exact same. We're taking this operation for x in range 10, and this should just work. Let's run it though, and see what happens. We get an invalid syntax. That's because we see generator expression equals to x times x, which right now x is not defined, but then we see a space and Python says, whoa, I'm not expecting anything else. By including the parentheses, which I'll do on the next line, we're specifically saying assign generator expression to this entire operation. Whatever the results inside the parentheses are is what generator expression gets tied to. So here we're going to see what we've seen before, which is the generator object. Now let's get into another gotcha related to generator expressions. So here I'm going to go ahead and uncomment this, and I still need generator expression 2. And what it's going to do is it's going to print start round 1, then it's going to iterate over generator expression 2, just like you can with any other thing, list, dictionaries, sets, and generators. Generators are intended to be looped through. And we're going to, let me copy this. We're going to say start 1, print the object, iterate through it, print the object again, and say end round 1. And let's see what the output is. Here, we get start round 1, we see the generator object, and keep in mind OX7F ends in 7O. I don't want to worry about the rest. We see 0, 1, 4, 9, 16, all the way through. And then when we print the generator again, we get the same memory reference. It's the same exact generator, end round 1. But what happens if we try to iterate over it too? So here we're just going to say print start round 2. We're going to try to iterate over it again, and then we'll just print end round 2 to let us know we're done. We see the first round works just fine, but with round 2, we get nothing. That's because a generator is a one-time loop operation, meaning once you hit the end of the loop, there's nothing more to do. You can't reset it. The only way to reset it is to start it over again or convert it into a list entirely in memory. That way Python never forgets what objects existed in space. Generators only keep track of the last value and the next value, and that's it. A list has to keep track of the entire list throughout its entire definition. Now, this for loop, there's actually a exception that gets passed off that this for loop gracefully handles that let me go ahead and show you now. So we'll comment this out and we'll create generator expression 3 and we'll print out using the keyword next. Next means, hey generator, give me the next item in that generation. It's like a very manual way of calling this for loop. So instead of saying for I in generator expression, we say generate expression next. We'll run this and we see we get 0. If we uncomment another line, we'll get 1, uncomment another line, we'll get 4, etc., etc. Let's go ahead and uncomment the rest of these. We see we get the entire output, but then we get a traceback of stop iteration. That's an exception I told you that the for loop gracefully handles, that if you were to call this manually, you're gonna have to create logic in here that handles this exception and handles it the way you intend it to. Now, like I said, you can't just restart a generator expression over again. So let me show you what I mean about turning it into a list. So here we're going to create our generate expression 4, same expression we've been doing, but we're going to create a variable called assigned list and then just call the list function around the generator expression that we made. And we'll go ahead and do a for loop around it. We can see it iterates just the same. In fact, if I print assigned list, we're going to see that it's just a list in space of what we expect to be generated from this. We have officially created what is a memory saving device into a completely in-memory list that is retained for the lifetime that this variable exists until garbage collection happens. But you might think that this is a bad thing because of memory reasons or CPU reasons, but there's a lot of other benefits. Since our data set here is low, we can iterate over this as many times as we need to. It's forever in memory, so we know exactly what exists. More specifically, Python knows exactly what exists in there. So don't you do this too often? If I do a generator expression, it's usually because I need the specific benefits of a generator. Often I create list comprehensions first or just use normal for loops. There's a yield keyword that lets you create generators in long form loops that I'm not going to go over here. Perhaps I'll do that in a different video. But really I don't do generators unless I know I need it. A list for me usually suffices because I usually work with pretty small data sets or not very CPU heavy data sets. But if you have high memory or high CPU needs, you might want to consider a generator, whether it be in a generator expression or use the yield keyword. It's important to know that it exists. But it's also important to know that you can use the list function wrapped around your generator to just debug what the output is. Now, I will also say one last note. Let's say that we had that 2-hour long high CPU bound limitation that says we're going to create 50 items in a generator and it's going to take 2 hours if we do it up front. But if we use a generator, we can reduce the amount of time that it takes and only calculate it when we absolutely need it. When you do a generator like this, you're setting yourself up for that level of success. But as soon as you call it in list, you're saying, okay, do the entire calculation right here, right now. So you basically get put in that same exact situation. It's not too worrisome, but it is important to know that that's how it functions. When you create lists like this, it's putting it in that list in memory right here, right now, as soon as I'm defining it. But that's all I've got today for loops. I had a lot of fun trying to record this. This was my third attempt because my first time Oh, that was confusing. It was very hard for me to follow what I was saying myself. And the second time, none of my audio got captured. So this was my third time. If you like my content, make sure you like and subscribe. Somewhere on the screen, I'll have that subscribe button. And if you have any requests for more videos, feel free to leave a comment. Or if you feel that anything I said was wrong or you just like what I'm doing, comment as well. I would like to see that. In future videos, hopefully someday I'll get rid of this grungy mattress. That grungy mattress, and you might see more cats in these videos as well. But I'll see you next time. Thanks for watching. See you later.